Have you ever wondered how software developers plan their code before writing it? This is where the concept of pseudocode comes in, and it's quite fascinating. Pseudocode is like a universal language among software developers, a high-level human-readable representation of a program or algorithm. It doesn't adhere to the syntax rules of any specific programming language. Think of it as a rough sketch or a draft, used in the early stages of software development. Here, the developer lays out the structure and logic of a solution before diving into the nitty-gritty of coding. It's like creating a roadmap, charting the course before embarking on a journey. This way, developers can focus on the what and how of the problem-solving process without getting tangled up in the syntax and rules of a particular programming language. So pseudocode is like a blueprint for a house, giving us a high-level view of what we want to build. Now, you might be wondering, what does pseudocode look like? Well, let's delve into the basic elements of pseudocode using a simple example: calculating the average score of a group of students. First off, we have variable declarations. This is where we set up the variables that we'll use throughout the program. In our example, we have 3 variables: total score, number of students, and average score. We use the pseudocode keyword set to initialize these variables. For instance, set total score to 0. Next, we have input and output statements. Read is used to take input from the user, and print is used to display output. In our example, we read the number of students and each student's score, and print the average score at the end. Then we have loop structures. These are used to repeat a block of code a certain number of times. In our example, we use a for loop to go through each student, read their score, and add it to the total score. Finally, we have decision structures, which we'll look at in more depth in another scene. They're used to perform different actions based on different conditions, but our current example doesn't require any. Let's take a quick look at our example again. We first declare our variables, then we read the number of students. We then loop through each student, read their score, and add it to the total. After the loop, we calculate the average score by dividing the total score by the number of students. Lastly, we print the average score. This example shows how pseudocode is structured and how it uses common language to express the logic of a program. The goal here is not to write perfect code, but to lay out the logic and flow of the program in a language-agnostic way. It's a blueprint, a plan for what your actual code will do. So as you can see, pseudocode uses common language to express the logic of a program in a way that's easy for anyone to understand. But why would developers use pseudocode instead of jumping straight into coding, you may wonder? Well, pseudocode serves as an invaluable tool that can greatly enhance the programming process. The benefits of using pseudocode are numerous and can save developers a lot of time and headaches down the line. One of the key benefits of pseudocode is its role in brainstorming and designing algorithms. Before writing any actual code, developers use pseudocode to outline the logic and structure of their programs, allowing them to see the big picture. This can help them identify potential issues early on, saving them the trouble of having to debug complex code later. It's like drawing a blueprint before building a house. You wouldn't start construction without a clear plan, would you? Another major advantage of pseudocode is that it's not tied to any specific programming language. This means it can be understood by developers regardless of their preferred coding language. As such, it can greatly facilitate communication within a diverse team. It's also particularly useful when you are working on a project that will be implemented in multiple languages. By using pseudocode, everyone can understand the logic and structure of the program, making it easier to translate into the actual code of various languages. Moreover, pseudocode encourages developers to focus more on the problem-solving aspect of programming rather than the technicalities of syntax. This not only enhances their problem-solving skills but also makes coding more enjoyable and less daunting, especially for beginners. Last but not least, pseudocode can function as a sort of documentation. By writing down the logic and structure of the program in a simple, understandable format, developers can easily refer back to it when they need to make changes or additions in the future. This is especially helpful in larger projects, where it can be easy to lose track of how different parts of the code interact with each other. In essence, pseudocode helps developers think through their code and communicate their ideas effectively, which often leads to better and more efficient code. So, how does one write pseudocode? Well, it's about simplifying the complex into understandable chunks. There's no hard and fast rule, but here are a few guidelines that might help. First, start by defining the problem you are trying to solve. This will form the basis of your pseudocode. Next, break down the problem into smaller, manageable tasks or steps. Think of it as creating a blueprint. You're outlining what needs to be done, without worrying about how it will be done in a specific programming language. Now write your steps in a plain, everyday language. Remember, pseudocode is not about syntax, it's about logic and structure. So use terms that are easy to understand. For example, instead of using complex programming terms, you can use words like read, write, calculate, and display. While writing, make sure to include all the necessary components of your solution. This includes inputs, processes, and outputs. For example, if you're writing a program to calculate the average score of students, your inputs would be the scores of the students. The process would be the calculation of the total and the average, and the output would be the average score. Also, remember to use control structures like loops and conditionals where necessary. These will help describe the flow of your program. Lastly, make your pseudocode as detailed as possible. The more detailed it is, the easier it will be to convert it into actual code later. And there you have it, a set of guidelines to help you write pseudocode. However, it's important to note that these are just guidelines. The actual process may vary depending on the problem you're solving and your personal style. Remember, the goal of pseudocode is to express the logic of a solution in a way that's easy for anyone to understand, not to write perfect code. Now that we've written our pseudocode, how do we turn it into actual code? It's a question that might be bouncing around your mind, but don't fret. While pseudocode isn't directly translatable to executable code, it serves as a powerful guide, a blueprint if you will, for your actual programming. Think of it as a recipe for a dish. The ingredients are your variables and functions, and the cooking instructions are your algorithms and control flows. You wouldn't just throw everything in a pot and hope it turns out okay, would you? No, you'd follow the recipe step by step. Similarly, when you're ready to code, you follow your pseudocode, translating each line or block into the syntax of your chosen language, be it Python, Java, JavaScript, or something else. If your pseudocode says for I from 1 to number of students do, this might become for int I equals sign 1, I equals sign number of students, I++. In Java, or for I in range, 1, number of students plus 1, in Python. The logic remains the same, but the syntax changes to fit the language. Pseudocode aids in structuring your code, keeping it clean and organized. It helps you focus on one piece at a time, reducing the risk of errors or bugs creeping in. It's like having a roadmap for your journey through the code, showing you where to go and what to do next. Moreover, pseudocode encourages good programming practices. By breaking down complex tasks into smaller, manageable parts, it promotes modularity and reusability. It also fosters readability and maintainability, making your code easier to understand and modify later on. Remember, the goal isn't to write perfect code on the first try, but to gradually refine and improve your solution. Pseudocode helps you get there, starting with a high-level overview and ending with a detailed, functioning program. So, pseudocode is not just a planning tool, but also a guide that helps developers write better code. It's a bridge that carries you from the realm of ideas to the concrete world of programming, making the coding process smoother and more efficient. Let's summarize what we've learned about pseudocode. Pseudocode is a high-level, human-readable representation of an algorithm or a program. It doesn't conform to the syntax rules of any specific programming language, making it a universal tool for expressing the logic and structure of a solution. Its elements include initializing variables with set, taking input with read, looping with for, and displaying output with print. Pseudocode is a trusted companion in the initial stages of software development. It helps to brainstorm, design algorithms, and convey ideas between team members. The beauty of pseudocode lies in its focus on logic and structure, rather than language-specific details. Moving from pseudocode to actual code is a seamless process, as you've already laid the groundwork by mapping out the logic and flow. So if you're ever asked to plan a software solution, don't forget to start with pseudocode.